Hello friends, here we will show you the case study of embedded system in hardware software co-design. Our objective is given in the abstract. Here we will see the architecture of the system tailored for a specific application frequently requires cooperation among hardware and software components. The design of this system is typically a compromise among a number of factors: cost, such like cost, performance, size, development time, power consumption, etc. To cope with these facilities and steady demanding of shorter time to market. A comprehensive strategy aiming at gathering all the involved aspects of the design is becoming mandatory. This new discipline, called co-design, considered in a concurrent manner all the activities involved in the design of a mixed hardware-software dedicated system, capturing of design specification and requirements, mapping of the design onto hardware and software domains, system synthesis, and design verification. Introduction: we will see the application in the domain of telecommunication, multimedia, automotive, and consumer markets make wide use of embedded system as an important of the global product. Usually, embedded systems are constituted one or more microcontroller or microprocessors to provide programmability of the system and interact with the digital analog components to receive data. We will see the design flow. For many years, design teams had to face the realities of combining hardware system with software algorithms to deliver the system capabilities and performance. The traditional design flow of embedded systems start from the requirements document, usually leading to an incomplete specification of the system. Given this document system, the architects define the set of system functions that must cooperate in order to satisfy the system requirements. Modeling and validation of these functions is performed by simulating programming language and execute. Furthermore, these phases occur prone since prototyping is usually manually performed, and therefore it is not possible to formally guarantee the equivalence between the specification and the software. Specification capture the desired system functionalities are expressed in formal model, and other is exploration. The formal model is used as input to analyze different design alternatives to identify the best one that satisfies all design constraints, both functional and non-functional. Hardware software interface synthesis and implementation, and fourth is co-verification. Here we can see the flow graph in which co-validation is given in co-simulation verification. First one is system verification, second is design space exploration, third is design refinement, fourth is co-synthesis. First is in system specification we will see function model and requirements, design spaces exploration in which is estimation, transformation, parsing. Similarly, in third we will see memories, interfacing, architectural mapping, and fourth co-synthesis part we will see software generation, hardware software synthesis, operating system interface generation. Here we will see the hardware software co-design is not a recent idea. It has been in industrial preface for a long time, but only recent gained attention in the research and EDMA communities for the dedicated hardware in order to cope with system requirements such as cost, performance, design, mobility, energy efficiency, size to market, etc. Thanks for watching it and making my assignment successful.